Hello and welcome everybody to the developer interview series. It's number 17 and it's my pleasure to welcome Alex Soto. Hello Alex, how are you?
Hello, Marcus. Yeah, I'm pretty fine and very excited to be in your podcast as well.
Thanks for taking the time. Where are you actually? I mean, physically, geographically, where are you?
Well, yeah, I'm in Barcelona. Currently, I'm at home, and yeah, and it's really nice place to live because of the weather. It's I have a lot of friends in Norway or in Germany, and you said, oh, it's snowing and so on. And here in Barcelona, we are sunny, and yeah, it's really awesome to be here.
I'm
Yeah,
kind of jealous, that's true. Um, do you mind introducing yourself a little bit to the audience? Who are you?
yeah, yeah. Well, my name is Alex. I'm a software engineer. Um, I work in Cytel, which is well, I will introduce you after a bit. And well, it's always a bit difficult to introduce me or define myself. I can define me as a passionate of Java wall and open source, and because of that passion, I'm leading two projects. One is NoSQL Unit, which is a framework for writing tests for NoSQL databases, and also ASCII Doctor J, which is the bridge between ASCII Doctor writing in Ruby and ASCII Doctor to be run in Java or JVM languages. And also I contribute in Arquillian, also in Tommy Drive, which is the company behind Tommy, I contribute to, and also a minor, contributions to open source project like Jackson, Flyway, or this, but it's minor contributions. A part of these things, I'm also an Arquillian Tech Evangelist. I'm a member of the GSR 374 expert group, which does JSON-P processing, which is going to be released in Java E8. Also, I'm the curator of lordofthejars.com. I'm coordinator at Barcelona Jack. I'm organizer of JBCN Conf, which is the first big company big conference that is going to be about Java in Spain. And yeah, I think that job. Yeah.
That's pretty much already a day job. What are you doing for a living? Like, what's your day job?
Yeah, my day job, I'm a software engineer architect in Cytel. Cytel is the worldwide leading company of electronic voting and election management. And basically, what I do is defining standards for the whole company for example, RESTful web services. So all the RESTful has similar, similar way and developed in the same technologies. Also, for example, take care of the security of the projects. So all the projects uses the same approach for authenticating and authorization issues. Also, I'm like an internal consultant where the teams comes to me and say, hey, I have this problem, how I can solve it, or can you review this, or this kind of internal consultancy, because this is an end company. It's a technological company. It's not a consultancy company. And well, and also creating some proof of concepts for some kind of problems that we find, because now we are moving to SaaS. And that means that we are starting to play with, for example, Mesos, Marathon, and all these new or trendy technologies, Docker also, and yeah, and it's this kind of I'm quite entertained, yeah.
Okay, and what is your most interesting topic that you are working on right now? I mean, in a professional or an open source world?
Yeah, no, currently I may say that I have like two great projects at the same time. A part of the work or my current job. This is, I mean, it's so interesting. But in the open source, well, I'm first involved in Arquillian Cube. I'm really interested in this project, which today we are going to see it. Also, I'm writing a book for Manning about Arquillian, and yeah, and as an expert group, as a member of extra group GSR 374, defining the specification for JSOP. This is the most challenging things that I'm doing nowadays.
Okay, you mentioned Arquillian Cube and you mentioned Docker, so this sounds like it's pretty bleeding edge. Well, what exactly is it?
Yeah, exactly is. Arquillian moves your test near to production, so you can start writing real tests. But when Docker becomes a trendy technology, or with the ban of Docker in many companies, like for example Google, Red Hat, and so on, we decided, or we have the vision of said, okay, we can even improve more this by moving tests even closest to production. And if you are using Docker in production, you can write tests and run it in Docker automatically. And so instead of writing tests that are pretty similar to production, we can say that you can start writing tests that will run in an infrastructure that will be exactly the same as in production. And that is what Arquillian Cube is.
Okay, I definitely want to see it. I mean, I love Arquillian. I've been member of the community for quite a while already. And so just show me the latest awesomeness, please.
Okay, it would be a pleasure. Okay, I've named this presentation as any resistance is futile, infrastructure bugs will be assimilated, because Arquillian Cube is about infrastructure bugs. Well, I've introduced myself. I'm Alex Soto. You can find me in GitHub as Lord of the Jars, and you can send me an email for any question or any communication you want to do with me. And today we're going to talk about Docker and boot to Docker, then about Arquillian. We're going to see a brief demo of how Arquillian works. Then we're going to see Arquillian Cube, which is an extension of Arquillian, how Arquillian Cube can be used, and finally, the next steps that we are thinking to implement in Arquillian Cube. So, what is Docker? Docker it's an open source project which automates or simplifies the deployment of applications in software containers. Keep in mind that these software containers are a virtualization in an open source level on Linux machines. It's different from, for example, VirtualBox, which is on a low level virtualization. It's some kind of hardware virtualization. And in Docker, it's about operative system level. Docker doesn't invent something new. It uses some already existing tools like cgroups or namespaces. But what really improves Docker is that it loves REST, which means that instead of having to run shell scripts to create a container or deploy a container, you can do it with REST. And that's awesome because opens big possibilities in the kind of integration with other tools. But the next question is, what is a software container? Well, a software container is a method that allows kernel, Linux kernel, to create multiple isolated user spaces. Normally, when you start a session, you only have one user space. But with software containers, you can have multiple instances in a simple session. And isolated between them. That means that each of these space has its own processes, disk space, network, users, groups, CPU, etc. all isolated. And that's a great step forward in standardizing the deployment process, because it's a container, and you can put this container and copy to any of the system that runs in Linux kernel, and it will run without any problem. The key point of software containers is that you don't have to take care about what's inside. I really like to compare, in fact, Docker does the same with these cargo containers. The cargo container, you can put there everything you want, but of course, you have to have some rules to not jump off, like, for example, the chair, or, for example, the space. But if you don't violate these rules, you can put everything there: a car, a TV, or a computer. If it fits inside the container, it's not a problem. A software container is exactly this thing. You can put there your application server, your libraries, your shell scripts, your database, whatever you want, if it fits inside the container. And when it's closed, it doesn't care what's inside. And that's a picture that's taken from Docker side, which you can see the difference between virtual machines and Docker. Virtual machines is, okay, you've got your server, your host operating system, of course, the hypervisor, and then you add another operating system, which can be 5 gigabytes, 10 gigabytes, because it's their old operating system. Then your binaries or your libraries, and finally your application. And probably all the people who use this VirtualBox will notice that when you start it, it takes a lot of time, like 1 or 2 minutes. But then it's Docker. Docker, it's in another way, because as we said, it's an operating system level. So you have your host OS, but see that now we don't have a guest OS. It's processes that run inside the same host, isolated, of course, but in the same host. That means that I'm pretty fast to start or to operate. But as we said, Docker is about Linux. So what's happened with Mac or Windows? The Docker guys created boot to Docker. Boot to Docker is a VirtualBox tiny core Linux. It's like a pretty fast Linux, which is, I think that it's 25 megabytes, and it's all in RAM, so it's fast. It comes with a Docker host. That means that because Docker loves REST, what you're doing from Windows or Mac is establishing communication using REST to that Docker host. And because that Docker host is running on a Linux, we can run the container there as well. And also there is recently Docker acquired a company called Kitematic that is some software which makes running Docker in macOS in a more fashion way. So how to build a container? You have 2 approaches. The first one is using Dockerfile. You can think about Dockerfile as a make file or a Maven POM file, or where you define what's going inside this container. This is one way. And when you have the Docker file, you can call Docker build and set the path where the Docker file is, and the Docker will create the container. Or if we know that there is an already container which fits for us, we can do a Docker pull and the name of the container. If it's already created, this will take the container. This is an example of Docker file. See that what you are doing here is setting a base container, and notice that you can add groups for this container, add users for this container. You can add environment variables, and these variables will be only for this container, although it's running in the same session. You can create files, users, run commands. In this case, we are getting Tommy from Apache side. We can expose ports, and also we can run commands. In this case, if you run this Docker file, what it's creating is a Docker container, which when you execute it, will start an Apache Tommy. How you can ship a container? We have seen that, okay, we've got the container, but we need to ship it in production servers or in pre-production, or or on your own computer, and that's done with a registry. You can think about registry as the Maven repository for jars, but this is for containers, and you can create your own private registries for your company, for example, inside your firewall, or you can use a public registry called Docker Hub, where you can publish your containers and everyone can get from there using the pull command. And if you want to ship your container to the registry, you only have to call docker push and the name of the container. And finally, when you want to run a container, you want to say, hey, Docker host, I want that you start a container. You can do it in different ways. In the first way, you are using a CentOS. You do a Docker run. Then options. In this case, I'm saying that I want an interactive console because I'm going to call /bin/bash. So in the first command, in fact, opens a CentOS and with a bash command, and I can then there put commands like ls, ps, and so on. And the second one is Docker run Tommy drive Tommy. This one is the name of the Docker, but I'm not saying that I want to execute any command. Why? Because the command is implicitly in the container. In this case, the command will be a start Tommy. So, a schema from an image that I take from Arun Gupta presentation. As you can see, we have a Docker client, which communicates with Docker host with REST. Notice that we have Docker Hub. This is where all the images, all the, let's say, containers are stored. Then you start to a Docker host and say, I want to run a container. So if the image is not in the Docker host, it's going to be downloaded from Docker Hub. Then you can have a lot of images downloaded. And then when you do a run, it takes one of these images and creates the container itself, the instance of the container. And notice that I've put here 2 ports. That's because Docker host uses the concept of port binding and expose port. Each container can expose 1 port. In this case, for example, container 1 can expose the 8080 port. But from outside, if you want to access this container, you will need to do it using the 8081. This is something that let us run several containers in different ports from outside. You can also access in a port which can be acceptable for your firewall or for any DNS rule. So this is Docker, and you can find a lot of reading or blog posts in the net about Docker. So I'm going to extend it more. And this is Arquillian. What is Arquillian? Okay, it's a middleware for your test. It's like this sentence. It's quite powerful, I think. When you put the middleware word in something, it means that it's something big, something that solves a big problem, and that's the case of Arquillian. What problem solves? Well, basically fills the gap of the automatic test when you want to move from unit test to integration test. If you have your enterprise application, probably you will write unit tests and it will be pretty fast and pretty easy because you are writing tests, which is the basic unit of a business method. So if you have any communication to external systems, you will mock it. And that's okay, and that's easy. But what's happened when you want to use or write integration tests? You have a problem. You have a problem because nowadays, almost all the, let's say, containers, it can be a servlet container, it can be a AGV container, it can be a CDI container, offer some features that are used in our code. We can think, for example, with security in database pool connection, injection, JMS, transactions, all this kind of stuff are managed by the container. And if we want to write our integration test in an automatic way, we have a big problem. The first is that we need a container. So we need to start a container and a stop container. The second problem is that we need to deploy something to that container. And the third one is that we need to execute the test in that container. And if you try to do this at home by yourself, you will see that you have a lot of problems. And basically what people did before Arquillian was or writing functional tests, like acceptance tests, for example, and don't write integration tests, or simply using a manual steps. So as we can see, a step after you write unit test, the step to integration tests is pretty hard. And Arquillian takes care of all this hard stuff, so you can write integration tests for your enterprise project as easy as possible. But the good news for Arquillian and for all of us is that Arquillian can be used not only for integration tests, but also for functional tests, security tests, or for example, integration testing. Arquillian was started as a framework for CDI, but it has been expanded a lot. It can be used in Java EE, but also in other technologies. You can use Arquillian in Spring. You can use Arquillian in Android applications. You can use it in Ruby applications, Groovy applications, and every kind of thing that you may require to test, you can do it with Arquillian in some way or another, but you can do it. And the thing is that it's open source. And I said it's open source because sometimes you can see that there are some community version and enterprise version and so on. And Arquillian isn't a true open source project. So let me show you an example. We've got the payment gateway. In this case, we are using CDI. And you said, okay, I want to inject here a payment that is qualified with credit card. So if we want to write an integration test for this, without Arquillian, we will do something like this, for example, creating the payment gateway and then setting manually the credential card payment with a setter method, and then call the do payment. So the quick question is, okay, we've got this integration test, which doesn't run inside a container, which is how it will work or it will run in production, and should it work when I deploy this code into my application server or into my servlet container? And we simply don't know. We don't know exactly for the reason that container has something to do with inject in this case. And if we, for example, don't create the qualifier perfectly, the instance would be null. And these kind of things won't be noticed in our test. So what we need is a way to write real tests, because real tests increase robustness, builds confidence, and increase certainty. Certainty that if it works on my machine, it also works on production, because our code is tested under the same environment, the same circumstances of our production product. So Arquillian takes care of all these plumbing steps of selecting a container, starting a container, stopping a container, deploying our code, running the test, and so on. So the first thing is selecting a container. This is the first step before starting using Arquillian. You can choose Tomcat, Wildfly, Tommy, Tomcat, Jetty, the Welt, WebSphere, WebLogic, Glassfish, and also there is an adapter, so you can deploy your test automatically to OpenShift. Then Arquillian starts or connect to the chosen container. I said start or connect because Arquillian have 3 modes of running. The first one is starting an embedded container. Nowadays, almost all the containers can start in embedded mode. So you can start in the same JVM of you're running the tests or the code, the application server. Also, you can start a managed application server, which means that you set the location where application server is installed, and Arquillian will go there and start it. Or also can use to connect to an already running containers. For example, you have in your server of the company Wildfly running, you can use this running server to run your tests, because instead of starting a new one, Arquillian will connect to that instance. Then Arquillian will package all your files, because if you are going to run some code inside a container, obviously you need to create your jar file, AR file, or WAR file, and this Arquillian can do it with one project which is called SwimWrap. And then run the test, because now we've got all WAR deployed, we can start running the test. And Arquillian have 2 modes of running the test. The first one is in container mode. In container mode means that the test is run inside the container too. It's it's packaged with your application and it's run inside the container. And this gives us big advantages, as we are going to see in the next slides. Or the other mode is as client, which means that the application is deployed, but the test is outside the container. We can think about like a browser. A browser is outside the container. So in this case, Arquillian, the only thing that does is starting a container and deploying the application, not running the test. The test is run by the client. Then, after the tests are run, it captures the result and send it back to the client, and undeploy the application and stop or disconnect from the container, because the test has been run. So you can undeploy the WAR file and stop the application server in case you have started. With code, how to add Arquillian? Pretty easy. We have a BOM file, which is a POM. You only have to add this to your pom.xml and you have Arquillian ready to be used. Then we need to choose an application server. And in this case, I've chosen Tommy Embedded. And to choose an application server, the only thing you need to do is add a jar in the class path. And Arquillian will automatically find it and act as consequently. So in this case, what Arquillian will do it is start an embedded Tommy, run the tests, deploy the application, run the tests, and then stop that embedded Tommy. Then we need to write the test. And there are, in this case, it's an in-container test, and there are some special things. The first one is that you need to annotate your JUnit test with run with and Arquillian.class. This is the runner of Arquillian. Then, as we said, we need a way to deploy our application to the container. And to do this thing, what you need to do is annotate one static method with deployment annotation. And using a run wrap, you create, in this case, a Java archive file, which is a jar, adding all the packages of our package org.superbis, and also add as manifest resource the bin.xml. This, if you run this code, you will see a logic jar file with all this content. I mean logic. I said logic because it's not a physically stored in your hard disk. Then, because this test is in container test, we can use CDI injections, CDI annotations like inject, or using a qualifier. We can use AGVs annotations because this test is run inside the container. It runs in the same environment. And then we can use the test annotation, and we can call pay using credit card from the payment gateway without any problem. This variable, the payment variable, it won't be null. It won't be null because it will be injected. Because, as I said, the test is run inside the container. And here you can see the difference with a client when you run a test and in as client mode. In this case, what we are doing is putting deployment annotation with the stable false. This makes that this test is going to be as client. So Arquillian won't package this test inside the container. Here we are creating a war file called hello.war, which only contains a hello world servlet. And then the method under test, you can use Arquillian resource URL. This URL is the URL of the application. So as you can see, because this is a client and you can think this class as a browser, the only thing that we can do is connect using a URL. You cannot use here inject or AGB annotation or whatever you think, because the test is outside the container. And that's important when you want to write a test, decide these things. And probably it will depend if you are going to write an integration test or a functional test, that you choose one or another. Let me show you in a moment the example, how it runs. We got here the payment test. I'm adding all that kind of stuff. Notice that I put here a breakpoint, and that's very important because this test is an in-container test. It's going to be run inside an application server, but I'm still able to debug from my IDE. Let's see it. Now, here it's just starting the Tommy. And now here I can debug my application. You can see here, wait, here, how the Tommy is opened and all this starting Tommy, initializing OpenAGB, now deployed application. And this is my application, what I've created, a jar file. This is what I've deployed here. Now you can see that I can deploy. And as I said, Here, the payment variable is not null. Here, it's an instance because it's injected by Arquillian. I can run this test. There is no answer, but it runs and it's green. And then, as you can see, the embedded Tommy is stopped. And here you can see the POM, as I said, which there is only the dependency of Tommy embedded and the Arquillian one, nothing more. This is the JUnit and the Java EE6 spec. So one of the principles of Arquillian is that we need to be able to write portable tests. Of course, there is not only one application server, so we need that our tests can run in Tommy, can run in Tomcat, can run in Wildfly, can run in Glassfish. So this is one of the principles of Arquillian, should be able to write portable tests. It should be able to execute from IDE and the build tool, for example, from Maven. And that's a really interesting feature, because let's say that you want to test something manually. You will run, for example, Maven package. It will take maybe 1 minute until it executes all the unit tests and compiles all the code and create the war. And then you put this war in the application server. And when you start the application, you see that you have missed one class or one file. And you say, oh, God, I need to spend 1 more minute in adding the file that I missed, run the Maven package, compile, and so on. And that's every time and every time and every time. But as we've seen in the demo, you can do it from the IDE. So it's pretty fast. You can run from your environment, because as developers, our environment is IDE, not the Maven or Gradle or whatever the build tool you want to use. You can run it directly from your IDE, see if it works, and then you can use the Maven build tool. Also, you can debug from your IDE, which is pretty useful, because when you find a bug, what you want to do is debug that bug. If you cannot debug, it's really hard to find what's wrong. Also, Arquillian reuse existing frameworks. Arquillian reuse, for example, Droidum for Android tests, reuse Selenium for functional web tests, reuse JCoco for coverage test. Also reuse, for example, Byteman for mocking 2.0 and so on. I mean that it doesn't provide a new framework. In fact, it reuses the existing ones. It's flexible because Java EE, it's quite big, has GMS, CDI, AGVs, JPA, and all these technologies can be tested with Arquillian. It's extensible because the things changes so quickly. So, for example, Arquillian now can be used with Docker, can be extended to be used with Docker without any problem. We have not touched anything from the core of Arquillian. And the last principle is that the ease of deployment. Sometimes you want to write a test that only uses 4 classes, for example, or 6 classes. And why you need to create a deployment of the whole application? If your application is like 2 megabytes, it's 2 megabytes of classes that must be class path scanned, packaged, run, etc. But if you only need 4 classes, with Arquillian and a Ring Wrap, you can do something that's called micro deployments. You create your WAR file only with these 4 classes. So it means that the deployment time is pretty fast. So as we have seen Arquillian, that we can write tests, integration tests, functional tests, etc., that will run inside our container. The container that is going to be used in production. But what's happened if we are going to use Docker on production? That our tests are not exactly executed in an environment as in production. Why? Because our product is running on a container, on Docker. So this led us to create Arquillian Cube. Arquillian Cube is an extension of Arquillian that manages the life cycle of Docker containers, which means that you can write your test, as we have seen, and instead of starting a container and stopping a container, what Arquillian Cube does is starting a Docker container and a stopping in a Docker container. It's exactly the same concept, but in an upper level. It uses Arquillian remote adapters because if you run an application server inside a Docker container, from the point of view of Arquillian, that application server, although it is running in our machine, it's a remote server because the server is already started by Docker container. So you only have to be aware of using the remote adapter of each application server. Also, Arquillian Cube let us orchestrate containers. Probably your application will need more than one container. The typical scenario can be an application server with a mail server and a database. So you need 3 containers. Also, Arquillian Cube has moved a step forward in the way of polyglot microservices. I mean that nowadays, when you want to start an application, you can say that you can choose 2 approaches. The first one is using an application server like Wildfly or Tommy, or using a containerless application, a containerless server, like for example, Netty, Node.js, Spring Boot, Undertow, all these, let's say, servers. It's not they are not a container like can be a container servlet or a container of AGVs. But the good news is that Arquillian Cube also supports this kind of developments. And finally, it's ready for boot to Docker. The problem of using boot to Docker is that, as we saw before, that it's a virtual machine. That means that every time you started that virtual machine, the IP can be different, and this will mean that your test should start failing if the IP is different in each environment. So what Arquillian Cube does is make a resolution of all that dynamic parameters of boot to Docker. So without touching anything, you can run the same test in different environments with different boot to Docker instances, and the test still runs correctly. So let's ship the first bug. In this case, I'm going to use a container called Tutum Tomcat, a version 7.0. We are only going to deploy one servlet called Hello World Servlet, and the test is going to be run as a client. Notice that this test is exactly the same test as we've seen before. There's no difference. This test can be run using the Arquillian core or using Arquillian Cube. It's exactly the same. The only difference would be where it's run. In one case, maybe it would be the local host or the server itself, and in other cases can be the Docker inside the Docker container. The next thing is adding the Arquillian Cube Docker dependency. And because we've said that we are going to use Tomcat and we need the remote adapter, we're going to add the Tomcat remote adapter. And finally, in Arquillian, there is one file called arquillian.xml, which is placed in the root of the class path. And in this case, what we are going to use is this file to configure the Docker extension. You put here the qualifier Docker. Notice that we are not setting where is the Docker host. It can be localhost or it can be a boot to Docker. But we don't have to set it because Arquillian Cube is smart enough to resolve this variable. Of course, you can set it manually if you want, but if you don't set it, Arquillian Cube will resolve for you. Then we need to set what is the image of our Docker container. In this case, as we said, Tutum Tomcat 7.0. We can set environment variables. This is something that you should see in this link. Here is what is explaining why we need to put all this kind of stuff. Notice here that we are using Docker server IP. This will be resolved at running time by Arquillian Cube to the real IP. So you don't have to worry if this IP is different because you are using a VirtualBox or not. This is resolved by Cube automatically. And finally, you can define the port bindings. In this case, you're defining that the 8089 port is exposed to the external, the same for 8088. But in this case, we are saying that the port 8081 from outside is mapped to 8080 from inside the container. And then here we configure the remote adapter. Let's see this example running. I got here the test as well. Here I defined, as I said, the configuration of the images. If you, I got here put to Docker. If I do a Docker PS, you can see that there is no running container. I put here a breakpoint. Again, from my IDE, I can put a breakpoint. There's no problem. Debug as JUnit. Okay. Sorry, because I have here some breakpoints. Okay, now. Okay, see, now that I am inside the test, this is the test that I've right. And if I go here and I do a Docker PS, you can see that the container is running here. It has been started by Arquillian Cube. It's after that, Arquillian has deployed our Hello Servlet class inside the Tomcat that is running inside the container. And now we are going to execute the test. And we have executed the test. And as you can see, green bar. And most important is that I'm going here. I want to go clear. And I'm doing here Docker PS. The container is closed. All these things automatically. I have not done any manual step, and that's very important. Also, as I said, we can orchestrate our test. In this case, I'm going to show you one Wildfly, a container with Wildfly, and another container with a database in H2. The Wildfly is created using the Docker file, and the H2 database is in this image. And in this case, is a container test. So the only thing that we need to do is, first of all, define Wirefly. In this case, we're defining, okay, I'm going to use Wirefly. Wirefly is going to be taken from this Docker file. Basically, this Docker file is pretty similar as the one I showed from Tony, but instead of Tony, it's Wirefly. We're exposing the ports and port binding. Then we are using a nice addition which is called extends. And I said, okay, I'm going to use Wirefly database and extends from Wirefly. It means that it uses all this information, but it creates a link. A link is a way of Docker, so you can communicate between containers. And in this case, I'm saying I want to link from to database container with an alias called database. And if you see here, the database container is an image of H2 and exposes all the ports. So if we run a test with this description, what we will see if we do a Docker PS would be two containers, one with Wirefly, another one with H2, and both of them communicated. So you can create an insert inside the Wirefly, and the container of the H2 will receive the update. As I said, you can also write tests for containerless applications. Of course, this application should run inside Docker. And in this case, I'm going to show you how to use Arquillian Cube to test Node.js application. The first thing is Arquillian test, of course, in Java. It could be in Ruby or any JVM language, but in this case, it's in Java. And what I'm creating here is a generic archive, which is called app.tar. Basically, is what's creating this is in a file called app.tar with index.js, which is a file for Node.js, and the package.json, which is a file required by Node.js applications. And here, I do exactly the same as in Tomcat, which is I want to get the URL of the server, of the Node.js server, and it's really awesome, this feature, because this Node.js application is running inside a container, but the URL to access that Node.js application is injected here. And then we can do an open stream and read the line and assert that that the returned, in this case, hello from inside the container is returned. One thing that we need to do is add the Arquillian Cube containerless dependency. That's because we need to say to Arquillian that it doesn't have to start or stop. Sorry, not a start or stop. I mean, establish a remote connection to the server because there is no container. And then you can see here the Docker file used. In this case, we are from Node container, which this container comes with a Node.js installed. We are creating a directory. Notice this one. It is another awesome feature from Cube, and it says, okay, I don't know what is the file that is going to need to be copied inside user source app, because it will be created but as rimwrap dynamically. So I'm going to use this variable, deployable file name, and then at runtime, Arquillian Cube will substitute this variable to the defined one in as rimwrap. In this case, it would use app.tar at runtime. Then installs npm, exposes the 8080 port, and finally starts npm. And if you run this test, Arquillian Cube will start a container with the application that we defined in our Arquillian test inside, running, and then it will execute the test. And here, as you can see, there is we are defining in this case a container called node with the Docker file and the port binding, and then we need to define that this node container, Docker container, this node is this one, is a containerless Docker. So the good news for all of us is that you can use these examples in your development machines, so you can reproduce infrastructure tests or be more confident on your code. But also it can be used for writing infrastructure tests to really avoid problems on production before you deploy your application. Because if you're using Docker, you can use Docker everywhere using the same software. The thing that you put inside the container is exactly the same thing that is going to be run in production. So you can create infrastructure tests that can be run in development machine. But also, really important thing is that although you're using polyglot microservices, which means that one service is in Java, another one with Node, another one with Salem, for example, it doesn't matter. Arquillian Cube can execute this kind of test too. So what's coming? Well, this past week we have released a new version of our Arquillian Cube, and now we are working in a new step, or a new step forward, a new way to write tests, and is using some other existing container technologies, like for example Apache Mesos, Marathon, Kubernetes. In this case, Kubernetes uses Docker, but you will be able to run tests using Kubernetes, or Docker Composer. And that's the plan. We are a really new project, but we have received really awesome feedback, and we are receiving a lot of pull requests from people that use it. So it's a project that it's growing pretty fast. You can see the slides here in my GitHub account in the repo Dex, and that's all. Thank you very much.
Thank you so much, Alex. That was amazing. I actually didn't know what Cube can do already. I'm kind of blown away. Thanks for all the extensive showcases, and I guess there are a lot of examples on the Arquillian GitHub repository, right?
Yeah, there you can find examples using Undertow, using Node.js, this orchestration between Wildfly and H2, in container tests using Docker. Yeah, there is a lot of examples. Also, you can do a lot of more things, like for example, starting when you arrive at your workplace, you start the container, and you can with your container started all the day, you can set that Arquillian Cube don't stop it. So it means that you are not going to spend time in starting and stopping the container. You can start it once, run all the tests during all the day with the same container, and Arquillian takes care of cleaning the environment. So you can be sure that you can write each test in an isolated way, but without spending time on starting and stopping the container, for example. So yeah, there is a lot of features there.
Still, I mean, even that was blazing fast. I haven't seen a big issue with that, at least not in your demo.
Yeah.
So very impressive. Alex, people can contribute by sending pull requests. Writing documentation, I guess, is another nice fancy feature that you're always looking for.
Yeah. Currently, we are writing documentation in a README in a README ASCII doc file, but it's like okay, I'm going to create this feature. I'm going to document this feature, and it's maybe we have talked with Aslak as well that we need to reorganize all the documentation. I think that we will need help in this direction to make that documentation a bit more helpful or easy for the readers, because now it's like you need to read the whole document to know something, and it's something that we need to improve. We know it.
Okay, fair enough. So whenever people feel like they want to contribute, they should just shoot you an email or reach out on Twitter, right? So that's the correct way to do it. Thanks again for your time. I hope you have a pleasant weekend because it's, thank God, Friday. So
Yeah,
um, I think we will meet again shortly somewhere around the world.
yeah.
Have a great day. It was a pleasure to have you here.
Okay, a pleasure was mine to be here with you today.